Today our lecture about kaluza Klein theory, 5-dimensional space-time, 5-dimensional Ricci tensor, 5-dimensional field Einstein field equation, and how to derive the motivation of that 5-dimensional or 4-dimensional. We know that the compactification between electricity and magnetism from the Maxwell equation is the Maxwell equation who will be compactification between electricity and magnetism, and from the special theory relativity, the space-time are be compactified and they are the interdependent and relative. And for general theory relativity, we have the curvature of space-time and the matter should be compactified. Now we have 5-dimensional space-time metric from kaluza-Klein theory, which is the space-time interval is d square equal to gab del za del zb, where ab runs from 0, 1, 2, 3, 4, and gab is the metric, the for 5-dimensional metric, and this is the 5-dimensional component, and za equal to x mu x5, where x mu is 1, 2, 3, 4, and x is a 5. The kaluza coordinate transform from the 1 plus 3-dimensional space-time as x mu tends to x mu 5 x mu x prime mu x of x. 1 plus 4-dimensional space-time is z prime of a of z is as same as like that 4-dimensional and 5-dimensional. This is the as similarly x5 equal to x prime mu x5 of x mu, so that the kaluza coordinate transformation is x mu prime mu x nu x prime 5 x5 of x mu. This is the main logic. Now the quanta variant from one coordinate to another coordinate, v prime mu del x prime mu del z va, and del x prime mu del x nu v nu. This is the 4-dimensional, and this is the extra term is the 5-dimensional. Del x prime 5 del z va del x prime 5 del x mu v mu del x prime 5 del x 5 del x v5, and del f per del x mu v mu plus v5. This is the quanta variant, and the covariant tensor is v prime mu del z b del x prime mu vb del x nu del x prime mu v nu plus del x 5 del x prime mu v5, and v prime 5 del zb del x prime 5 vb del x nu del x prime 5 v nu del x 5 del x prime 5 v nu, and v5 is a covariant tensor, and the quantavariant tensor rank to t prime ab equal to del z prime a del z c del z prime b del z d t c d. And 4-dimensional part of transformation, we note that del prime x mu equal to del prime mu del x rho del prime nu del x sigma t rho sigma. This is the 4-dimensional transformation for quantavariant second rank tensor. Now the fifth component t prime mu 5 del x prime mu del x nu del f per del x or t nu rho plus del x prime mu del x nu t nu 5, and t is t prime 5 del x del f del x mu del f del x nu t mu nu del f del x nu t nu 5 plus del f del x nu t 5 nu del t 5. And now we have t prime ab del z prime del z c del z d del z prime b t c d. This is the second rank tensor, mixed tensor, and t prime mu 5 del z prime mu del z c del z d del x prime 5 del t c d del t prime mu del x nu del d del x prime mu del t nu faro now till nu d, and del x prime mu del x nu equal to del x rho del x 5 del nu rho del x 5 del x prime 5 t nu 5, and del x prime mu del x nu t nu 5. This is the transformation of the 4-dimensional quantavariant tensor. Now the second rank covariant tensor tab t prime ab del z c del z prime a del z d del z prime b t c d. Now for the 4-dimensional t prime mu nu del z c del x prime mu del z d del x prime nu t c d t nu 5 t prime nu 5 del z c del x prime mu del z d del x prime 5 del t c d, and t prime 5 del z c del x prime mu del z d del x prime 5 t c d equal to t 5. Now showing the t 5 transformation as the 4-dimensional scalar. Now the one component relation. This is the fifth matrix, and this is the four component of the covariant tensor, second rank 1 tensor. There is the fifth component of the rank 2 rank 1 tensor, 5 dimensional, and this is the invariant from one coordinate to another coordinate. We have v prime mu minus g mu 5 g 5 v 5. Now we have del x prime mu v new del x 5 del x prime mu d v new minus del x prime mu del x rho del x prime 5 d new rho plus del x 5 del x prime mu del x rho del x prime 5 g 5 rho plus del x prime mu del x 5 del x prime 5 g new 5 plus del x 5 del x prime mu del x 5 del x prime 5 g 5 and v 5 g 5. This is the relation. Now we have del x prime mu v new plus del x 5 del x prime mu v mu minus v 5 minus del x prime mu g new 5 del x 5 del x prime mu d 5. Now we have del x prime mu v new g mu 5 g 5 v 5. Now the kaluza metric. For 5-dimensional metric, GAB is the 5-dimensional symmetric covariant tensor, and it inverse is GAB, which is the upper index. Now this is the satisfies this relation GAB equal to GBC equal to delta AC, which is the 5 component of the Koneca delta function. Now in 5-dimensional space-time are rises and lowered by the 5-dimensional metric. We have this is the 5-dimensional metric. This can be rises index, and this can be which multiply. This is the rises index which multiply this metric, and we have this is the lowering index, and this is the metric, and we multiplied by it by the lowering index. We have the rises index of VF. This is the summation between quantavariant and covariant. Now 4-dimensional small matrix, we have G mu equal to G mu nu. This is the simple relation for 4-dimensional. Is the now we how to relate the G mu nu with the G mu nu in the 5-dimensionals. We have now how to relate G mu nu to G mu nu. We have the covariant 4-dimensional space metric, and we have V mu equal to minus G mu 5 v 5 G mu nu V nu. Does the transform 4-dimensional covariant vector corresponding to VA if the 4-dimensional matrix denoted by G mu nu. Okay. Now we have V mu G mu a VA G mu 5 V nu G mu 5 V mu. So we have G mu a minus G mu nu V nu G mu 5 G 5 V 5 minus G 5 V 5. G mu nu minus G mu nu V nu G 5 mu G 5 V 5 minus G 5 V 5. Now V5 equal to G5 VA equal to G5 mu V mu G5 V5 and G5 V5 equal to V5 minus G5 mu V mu. So we have G mu nu minus G mu nu V nu G mu 5 G mu 5 G5 V nu, and we have G mu nu equal to G mu nu minus G mu 5 G nu 5 G5. Relating the G mu nu with G mu nu, we have G mu nu equal to G mu nu plus G mu 5 G nu 5 G5, and G mu 5 equal to G5 mu and G5 equal to G5. This is the lower index matrix for the 5-dimensional. We have this is the upper metric. This is we have G mu nu G mu 5 G nu 5 G5 G mu 5 G5 nu G5. This is the metric for 5-dimensional. This is the 5 component. Now GAB for upper index G mu nu minus G mu nu G nu 5 G5 minus G nu mu G mu nu G5 1 by G mu 5 plus G mu nu G5 mu G nu 5 G5 the whole square. Now the geodetic equation. We next take up the geodetic equation in kaluza theory. In the order bring out the essential. We take the detour of the four-dimensional geodetic equation. We know that we derive earlier video, which is the four-dimensional, and four-dimensional theory relative magnetism is not to be introduced by the hand. So geodetic equation in the presence of electromagnetic field is generalized by the Lorentz force equation, and we have dp mu ds m da mu ds q by the c f mu nu g mu. F mu nu, where is del mu a nu del nu a mu for in flat and to the curved space time. Now we have four-dimensional equal to dp mu ds equal to m da mu ds q by the c f mu nu u nu. With this f mu nu equal to del mu a nu del nu a mu is the flat to curved space time. Now to flat to curved space time, this is the flat space time equation, and this is the curved space time equation. D square x mu ds square plus gamma mu nu rho del x nu ds del x rho ds 1 by the m f mu, or f mu equal to q by the c f mu nu u nu. For this the consideration for now d part ds equal to d part ds g mu nu dx nu ds. We have d part ds g mu nu dx mu g mu nu dx nu ds equal to del rho g mu nu. First we derivative this term, and then we have del rho g mu nu dx rho ds dx nu ds g mu nu d square x nu ds square. We did a derivative that term and by the factor dx rho, and we derivative this term. Now we have d part ds g mu nu dx nu ds del rho g mu nu dx rho ds dx nu ds g mu nu 1 by the f nu minus gamma nu alpha beta a dx alpha ds dx beta ds. Now we have this, rearrange this and put on this del rho g mu nu dx rho ds dx nu ds gamma alpha beta comma mu dx alpha ds dx beta ds 1 by the f mu. Now dx rho g mu nu dx rho ds dx nu ds minus gamma rho nu comma mu dx rho ds dx nu ds plus 1 by the f mu. Now we have dx rho ds dx nu ds del rho g mu nu minus half del rho g nu mu and half del rho g mu rho g rho mu plus half del rho g rho mu plus 1 by the del mu. Now equal to dx rho ds dx nu ds 1 by the half del rho g mu nu minus del rho g rho mu plus 1 by 1 divided to del mu del rho nu plus a mu del mu. Now this is the equivalence equation of the geodesic equation of the four-dimensional metric g mu presence of the electromagnetic interaction. For electromagnetic presence of the electromagnetic field, electromagnetic presence, and then we have this is the geodesic equation. Now we have returned to the kaluza theory by the geodesic equation for five-dimensional becomes. This is the equivalence equation of the geodesic equation presence of electromagnetic field. Okay. Now we return to the five-dimensional geodesic equation. This is the Christoffel symbol gamma in five dimensional is denoted as delta, and z is the x is the z we know earlier, and d square z a d a square plus delta a b c. This is the Christoffel symbol for five-dimensional del z b ds del z c ds equal to 0. And now delta a b equal to g a d delta b comma c b c comma d half g a d del b del c d minus del c del b d plus del d del bc. Now delta a b c is the five-dimensional Christoffel connection. How five-dimensional Christoffel connection? How for now for the free particle del a equal to del part del z a. Consider the equation d part ds g a b d d g d z b ds d part ds d g a b ds d z b ds equal to del c g a b del z c del s ds del z b ds plus g a b d square s d b square. Now d part ds g a b d z b ds del c gab del zc del s del zb del s plus del gab minus delta bcd del zc ds del zd ds del c gab del zc ds del zd del zb ds minus delta cd del zc s del zds. Now for the s is the parameter for the path integral of the five-dimensional space-time. For the path of the five-dimensional connection of the Histable symbol, and for the free particle, this is all about free particle. No presence of the electromagnetism. Now del C GAB del ZC DS del ZB DS minus half del C GDA del D GCDA minus del A GCD del ZC DS del ZD DS half del ZC DS del ZD DS del C GAB del B GCA half del A GCD del C del S del ZD DLS. As from the term the antisymmetric C tends to be while the prefactor is the symmetric. This is the contribution vanishing leaving the term that we have. This is the antisymmetric. This is the antisymmetric with the preventing the antisymmetric, symmetric and antisymmetric. We have d per ds gab del zb ds minus of del a gcd del zc ds del zd ds. This is the geodesic equation for the no force as such in five-dimensional equation. It is the for the motion of the free particle in five-dimensional space-time. Okay, now furthermore we take the assumption that the component of the metric GAB are taken as to be independent of the fifth coordinate. Then a equal to 5 part, we have d per ds g 5b dzb ds equal to a equal to constant. This is the assumption, our assumption. This is the very important assumption. Now g5 mu dx mu ds plus g55 dx5 ds equal to a equal to mu. Now we have d per ds g mu 5 del zb ds minus of del mu gcd del zc ds del zd ds. Now d per ds g mu b del zb ds d per ds g mu nu del x nu ds del mu 5 del x mu 5 ds d per ds g mu nu dx nu ds d mu 5 g nu 5 d 5 dx nu d5 d mu 5 dx 5 ds d per ds g mu nu dx nu ds g mu 5 g 5 g nu 5 g dx nu ds d 5 g 5 dx 5 ds d per ds g mu 5 dx nu ds a d per ds g. This is the constant term, so we have d per ds g mu 5 g 5. Now we have half gunito half d del mu g cd del zc ds del zd ds half del mu g nu rho dx mu ds dx rho ds plus dx mu dx nu ds dx nu 5 dx mu ds dx 5 ds half del mu g 5 dx 5 ds dx 5 dx. Now we have del mu half del mu g nu rho plus g nu 5 d 5 g 5 dx nu ds dx rho ds plus del mu dx nu 5 dx nu 5 ds dx nu d per ds dx 5 per ds half del x del mu g 5 dx 5 ds dx nu ds. Now we have half del mu g nu rho del x nu ds del x rho ds plus half del mu dx g nu 5 g 5 g rho 5 del x nu ds del x rho ds plus half del mu g nu 5 del dx nu ds dx 5 ds half dx del mu g 5 del x mu 5 ds del x 5 ds. Now we have d per ds g mu nu dx nu ds minus of g nu minus of del mu dx g nu rho dx nu ds dx rho ds equal to half del mu g nu 5 d rho 5 g 5 dx nu ds dx rho ds del nu 5 dx 5 ds dx nu ds half del mu g 5 dx 5 ds dx 5 ds minus a d per ds g mu 5 g 5. Now the comparison this with the four-dimensional geodesic equation, we observe that the force in the kaluza theory, we have the force in the kaluza theory, we have the force in the kaluza theory, and the four-dimensional space-time emerging the four-dimensional kaluza theory particle. What is the origin? The free particle five-dimensional experience after the four-dimensional. What is the force? What is the force? What is the force? F mu divided m del mu g mu 5 del 5 g rho 5 dx nu ds dx rho ds plus half g nu 5 d rho 5 g 5 square del mu g 5 del x nu ds d rho ds plus g 5 del nu dx nu 5 d 5 dx nu ds dx5 ds d nu 5 d 5 del mu d 5 del x nu ds del x5 ds half d mu g 5 del x mu 5 ds del x5 ds minus a del mu g mu 5 d 5 dx nu ds5. This is the this is the five. When our assumption is five dimensional, we the for the free space for the five dimensional, this is in converted to the four dimensional, we have the force of the electricity magnetism. This is the main condition. Now the five dimensional momentum, the five-dimensional momentum PA equal to mgab del zb del s a equal to 5 p5 equal to mg5b del zb ds a m is a constant, p mu equal to mg mu 5 del zb ds and mg mu nu dx nu ds mg mu 5 del x 5 ds mg mu nu dx nu ds a m alpha mu 7. The five-dimensional Christopher connection, we have the five-dimensional Christopher connection. Delta A B C G A D delta B C D half G A D del B G C D plus del C G B D minus del D G B C. Now on the delta A 5 is half minus half G A D del D G 5 minus half D A mu del mu G 5 delta mu 5 equal to minus G mu nu del nu G 5 delta 5 delta 5 alpha half G mu nu A mu del nu A 5. Now del A B5 half G A D del B G 5D minus G del D G B del B5 del mu 5 del nu 5 equal to half G 5 divided to G nu rho A nu rho minus alpha divided to G mu 5 A nu del rho G 5 D delta 5 mu 5 minus alpha square divided to G 5 G nu rho A rho A mu nu plus alpha square divided to G nu rho A rho A mu del nu G 5 plus half D 5 del mu A 5 G 5. Now where A alpha equal to Q divided MC, where alpha is Q divided MC A. This is the constant. We assume that, and Q divided MC. A is a G5 mu Gx mu 5 ds G5 dx5 mu ds. This is the alpha. This is the very important constant. The constant, not constant. This is the very important. This is the constant. This is very important term. Now G delta 5 mu nu half G mu 5 G half G 5 rho del mu G nu rho del nu G mu rho minus del rho G mu nu half plus half G 5 del mu G nu 5 plus del nu G mu 5 equal to delta 5 mu nu minus half A rho del gamma rho mu nu minus del alpha cube divided to G 5 G rho sigma n sigma. Now A nu G mu rho n mu F nu rho plus alpha divided to A nu plus A nu plus alpha cube divided to G rho sigma A sigma del rho G 5 A nu and plus alpha divided to G 5 A mu G 5 A nu del nu G 5 A mu. Now G 5 mu 5 G divided G 5 alpha A mu of x. Now the fourth condition is fourth term is A mu nu rho half G mu D del nu G rho D del rho G nu D del D G nu 5 half G mu sigma del nu G rho sigma del rho G nu del D nu sigma and D del sigma del nu rho plus half G mu 5 del nu D rho 5 del rho del nu 5. Now we have del mu nu rho gamma mu nu rho alpha square divided to g55 g mu sigma a rho g f nu sigma a rho sigma minus alpha divided to g mu sigma del sigma g55 a nu a rho. Now the geodesic equation in 5 dimension. Geodesic equation, this is the geodesic equation. We have g mu nu d square x mu d square gamma mu alpha beta dx alpha ds dx beta ds dx beta ds and d per ds g mu nu d per dx half del nu g alpha beta dx alpha ds dx beta dx. Now we have d square x mu dx square gamma mu nu rho dx mu ds dx rho ds plus alpha f g mu sigma f nu sigma d x nu ds minus a square divided 2g55 square g mu sigma del rho g55. Now d square x mu ds square equal to delta mu bc del dzb ds dzc ds equal to 0. Now we have d square x mu ds square plus delta mu nu rho dx nu ds dx rho ds plus 2 delta mu nu 5 d delta dx nu ds dx 5 ds plus d delta mu 5 del dx 5 ds the whole square divided equal to 0. Now d square x mu ds square plus gamma mu nu rho alpha square divided to d 5 g mu sigma a rho g nu sigma a nu g rho sigma plus minus alpha square divided to g mu sigma del sigma g 5 del nu a rho dx mu ds dx rho ds plus half alpha g 5 alpha plus alpha g55 divided to g mu sigma f nu sigma minus alpha divided to g mu sigma a nu del sigma g55. Now dx mu ds dx 5 ds minus divided 1 divided to g mu sigma del sigma g55 dx 5 ds dx 5 ds equal to 0. Alpha a rho ds plus dx 5 ds a divided g55. Now alpha square g55 g mu sigma a rho f nu sigma dx nu ds dx rho ds plus alpha g55 d g mu sigma f nu sigma dx nu ds dx 5 ds equal to alpha g55 g mu sigma f nu sigma dx nu ds alpha a rho dx rho ds plus dx 5 ds alpha g mu sigma f nu sigma a dx nu ds. Now we have d square x5 ds square minus delta 5 bc dzb ds dzc ds. Now this is we put that value alpha g55 a mu dx mu ds g55 dx nu ds equal to a. This is the condition. And d square x5 ds square minus alpha g55 del rho g55 a mu dx rho d5 ds and dx mu ds minus alpha del rho a mu dx rho ds dx mu ds minus alpha a mu d square a mu ds square minus 1 divided g55 del rho g55 dx rho ds dx 5 ds d square x5 ds square minus alpha divided g55 del x rho d55 a mu dx rho ds dx mu ds minus alpha del rho a mu del x rho ds del x mu ds alpha a mu gamma mu rho mu sigma rho dx mu ds dx rho ds plus alpha square g mu sigma a mu d f mu sigma dx nu ds minus alpha a square alpha do g55 square a mu g mu nu sigma square del sigma g55 minus g55 del rho g55 dx rho ds dx mu ds. Now minus delta 5 bc g zb ds dzc ds. Now delta 5 bc g zb ds d 5 bc ds alpha a sigma gamma sigma mu nu dx mu ds dx nu ds plus alpha cube g55 rho g rho sigma a sigma a nu f mu sigma gx mu ds dx nu ds minus alpha del mu j nu dx mu ds dx nu ds minus alpha cube divided to g rho sigma a sigma del rho g55 a mu a nu dx mu ds dx nu ds minus alpha g55 del mu g55 del a nu gx nu ds dx nu ds plus alpha square g55 d nu sigma nu rho a rho a mu nu dx mu ds dx5 ds minus alpha square g nu sigma a rho a mu del mu g55 dx mu ds dx5 ds minus del mu g55 d55 dx mu ds dx5 dx5 ds minus alpha g mu nu dx mu a mu del mu g55 del x5 del a ds del x5 ds. Now we have minus delta 5 bc dzb ds dzc ds equal to alpha a sigma gamma sigma mu nu dx mu ds dx nu ds plus a alpha g nu sigma a rho a mu nu dx mu ds minus alpha del mu de nu dx5 mu ds dx nu ds minus a square alpha 2 g55 square d rho sigma a sigma del rho g55 minus alpha g55 square del a mu del g55 dx mu ds. Now 5-dimensional Ricky tensor. This is the this is the for geodesic equation in 5-dimensional. Now 5-dimensional Ricky tensor. 5-dimensional Ricky tensor is the similar we have this is the first is this is denoted as r tilde ab. This is the 5-dimensional Ricky tensor, which 4-dimensional is r mu nu, and this is the r tilde ab. Del c delta c ab del b delta c ac plus delta c dc delta d ab delta c bd delta d ca. Now g55 tilde r55 tilde minus alpha square divided 4 g55 square g mu 5 g mu rho g nu sigma f mu sigma nu sigma f mu sigma minus half g lambda nu del nu g55 this is the covariant derivative with respect to lambda plus 4 1 divided 4 g55 g nu 5 del mu g55 del rho g55. Now r tilde mu 5 alpha divided to g55 del nu g nu rho f mu rho minus g c rho sigma g nu sigma gamma nu rho sigma plus g nu sigma f mu sigma gamma rho nu rho minus alpha cube divided 4 g55 square a mu g sigma mu nu g sigma nu f mu sigma plus alpha 3 alpha divided 4 g nu sigma del nu g55 f mu rho minus alpha divided to g nu sigma a mu del rho g55 with covariant derivative nu plus alpha g55 g rho sigma del rho g55 del delta g55 a mu. Now we have del mu g nu sigma f mu g nu rho f mu rho minus g rho sigma f nu sigma f nu rho mu g mu f mu sigma gamma rho nu sigma rho gamma rho nu rho equal to del nu gamma nu mu gamma minus gamma rho nu gamma nu rho mu gamma nu gamma rho nu equal to gamma nu mu with covariant relation with respect to f equal to f. This is the defined as we define as this is the f. This is the above equation we can be written as. Now then the expression r tilde mu 5 alpha divided to g55 a mu alpha cube divided for g55 square a mu f plus g 3 alpha divided for g nu rho del nu g55 del mu del f mu rho alpha divided for g nu sigma a mu del rho g55 with covariant derivative with respect to nu plus alpha 4 g55 g rho delta del rho g55 d delta g55 a mu. Now this is the r tilde mu nu equal to r tilde mu nu r mu nu. This is the Ricky tensor in 4-dimensional. This is the Ricky tensor in 5-dimensional. R mu nu. This is the component of 4-dimensional. This is the total relation is relation as in 5-dimensional. This is the Ricky tensor in 4-dimensional. R mu nu alpha square g55 divided to f rho mu f nu rho plus alpha square divided to g55 a mu f nu a nu f mu plus alpha to the power 4 divided 4 g55 square f a mu a nu 3 alpha square divided for a rho g55 a mu g rho mu a nu g rho mu minus alpha square divided to g rho sigma d sigma g55 rho with respect to covariant derivative with respect to rho a mu minus 1 divided to g55 a nu g55 with covariant derivative with respect to mu minus 1 divided for g55 square a mu del mu g55 del nu g55 plus alpha divided for g mu 55 g rho sigma del sig rho g55 del sigma g55 a mu nu. This is the ultimate relation in 5 dimension. Now r tilde equal to gab, r tilde gab, this is the Ricci scalar, and we have g mu nu r tilde mu nu plus 2 g mu 5 r tilde mu 5 plus g 5 r tilde 5 5. Okay, this is 2 here, this is the mu 5, and this is the rearrange this, combine this 5 mu. For this there is a 2 g mu 5 r tilde mu nu plus 2 minus alpha g mu nu a nu r tilde mu 5 plus 1 by the g 5 5 plus alpha square g mu nu a mu r tilde mu nu r minus equal to r minus alpha square divided to g 5 5 a minus 1 divided g 5 5 g mu nu del nu g 5 5 with respect to mu. Now the Einstein field equation in the 5 dimension. This is the ultimate goal. Einstein equation for the 5 dimension. Now r tilde mu nu minus half gab r tilde equal to 0. For there is no matter, and no energy momentum tensor, there is no mass and 5 dimensional curvature is r tilde equal to r minus alpha square divided for g 5 5 a minus 1 by 3 divided r g 5 5 a mu nu del nu g 5 5 with respect to mu equal to 0. Now r tilde ab equal to 0. Let us first consider r tilde 5 5 equal to 0. Now we have g lambda mu del mu g 5 5 with covariant derivative with respect to lambda 1 minus 1 divided half g 5 5 del lambda g 5 5 del mu g 5 5 alpha square divided to g 5 5 square f, where f is a mu nu. This is the written is that f equal to a mu nu. Now r tilde mu 5 equal to 0 alpha divided to g 5 5 a mu nu a mu f mu g 3 alpha divided for a nu g 5 5 m nu mu nu mu minus alpha divided for a mu alpha square divided to a g 5 5 square f minus d nu 5 del rho g 5 5 nu half g 5 5 rho sigma del rho g 5 5 del delta g 5 5. Now r tilde 5 5 equal to 0 f mu equal to minus 3 divided to g 5 5 del nu g 5 5 f nu mu. Now f mu equal to f nu mu covariant to respect to nu. So g tilde mu nu g mu rho sigma g nu sigma equal to f mu sigma with respect to coordination nu minus 3 by 2 g 5 5 del nu g 5 5 f nu mu. Now g nu sigma f mu sigma with respect to coordination to nu minus 3 by 2 g 5 5 del nu g 5 5 del nu sigma f sigma. So we have r mu nu minus alpha square divided to g 5 5 f rho mu f nu rho minus 1 divided to g 5 5 del nu g 5 5 mu minus 1 by the 4 1 divided for g 5 5 square minus equal to del mu g 5 5 del nu g 5 equal to 0. This is the r tilde equal to 0. So r equal to alpha square divided for g 5 5 a plus g 5 5 g rho sigma del sigma g 5 5 with covariant energy with respect to rho. With respect to rho. Now the Einstein field equation. In 5 dimensional Einstein field equation, free space, there is no matter and no energy momentum tensor. We have r mu nu minus half g mu nu r equal to alpha square divided to g 5 5 f rho mu f nu rho minus half g mu nu f plus 1 divided to g 5 5 del nu g 5 5 with covariant derivative with respect to mu minus g mu nu g rho sigma del rho sigma d 5 5 with respect to coordinate with respect to rho plus 1 divided for g 5 5 square del mu g 5 5 del nu g 5 5. Now this is the for this 4-dimensional free space, this is equal to 0. For 4-dimensional, this is equal to 0. R mu nu minus half g mu nu are equal to 0 for 4-dimensional. But in 5-dimension, r mu nu minus half g mu nu are equal to something term. This is the something term for 5 dimension. So this is, now we have for 5 dimension, this is the 4th dimension of the energy momentum tensor relation. This is term of the 4th dimension. This is the 4th dimension curvature. This is the 4th dimensional energy momentum tensor. This is the T mu nu minus K T mu nu. This is so there is a few important result. This is the traceless electromagnetism momentum tensor. This is, it is very revealing that observe the energy momentum tensor emerge the natural kaluza theory. Next, many author the kaluza, many author and many teacher kaluza scalar G55 to be a constant. This is incorrect. G55 is not a constant. We assume that the G55 is a constant, but not